the square root of 3364 and 1936 and hence find the value of root of 0.3364 plus root of 0.1936, root of 0.3364 minus root of 0.1936. In order to solve this one, first we need to find what is the square root of 3364 and we need to find what is the square root of 1936. After finding the value of these two, we can substitute in this one and we can find the value. For solving this, let me find what is 3364 square root and square root of 1936 using long division method. So square root of 3364, first we need to divide this into pairs from right to left. So I am dividing into pairs. 33 is not a perfect square. The perfect square less than 33 is 25. So 5 5s are 25. Subtracting these two, we get remainder as 8 here. 5 plus 5, 10. Next, let me bring 64 here. So since the last digit, unit digit is 4, there is only two possibilities. One is 2 2s are 4 and then 8 8s are 64. 2 is not possible because it is a bigger number. So let's go with 8. 108 into 8. 8 8s are 64, balance 6. 8 zeros are 0 plus 6, 6. 8 1s are 8. So obviously it is 8 times. So 8, 8, it is 864. So the remainder is 0. Therefore, the value of root of 3364 is equal to 58. Again here, 1936, 19 and 36. So dividing we get 19 and 36 from right to left. Since 19 is not a perfect square, we need to find a perfect square. The less than perfect square is 4 4s are 16. So 4 4s are 16. Subtracting we get 3. Let me bring the next one down, which is 336. What is the unit digit here? 6. Now, 4 plus 4, 8. When we get 6, 4 4s are 16 and 6 6 are 36. So, the unit digit is 6 for both the numbers. Let us try with 4. 8, 4 into 4. 4 4s are 16, balance 1, 4 8s are 32 plus 1, 33. So it is 4 times. 4 4s are 336 and remainder is 0. So root of 1936 is nothing but 44. Now we can substitute here. We know that square root of 0.3364 can be written as, since it has 4 decimal points, we can convert this to fraction by writing root of 3364 divided by 10,000. So here we have root of 3364. What is root of 3364? 58. Square root of 58 and 10,000, root of 10,000. So this here we can write 58 by root of 10,000 is nothing but 100. So in denominator we have 100. So the decimal point moves 2 places to the left. So we get the answer as 0.58. Hence, square root of 0.3364 is nothing but 0.58. In the similar way, square root of 0.1936, okay, we can write in fraction as 1936 by 10,000. So 1936 we found value as 44. By 10,000 it is nothing but 100. So the decimal points move 2 places to the left. So we get 0.44. 0.1936 is equal to 0.44. In question we can substitute these values. Substituting the known values we get 0.58 8 plus 0.44 divided by 0.58 minus 0.44. So adding 0.58 and 0.44, we get 1.02. Subtracting 0.58 and 0.44, we get 0.14. In numerator and denominator, we have a decimal number. Let me multiply and divide this by 100 so that the value doesn't change. So multiplying and dividing by 100, the decimal point moves 2 places. So we get 102 here. The decimal point moves 2 places. We get 14. 104 by 14 dividing by 2 table. Numerator it is 51 and denominator it is 7. So the answer is 51 by 7. We can change it to mixed fraction. 51 by 7. We know that 7 sevens are 49. Remainder 2. This is quotient, remainder and divisor. We know that the general form of a mixed fraction is quotient, remainder by divisor. So substituting in that form, quotient is 7, remainder is 2, by divisor is 7. So therefore the final answer is 7 2 by 7. Next sum. Find the least number which must be subtracted from 2361 to make it a perfect square. So we need to find what is the least number that must be subtracted since 2361 is not a perfect square. In order to convert this, we need to find long division method. Let's use long division method. First, we need to divide this into pairs. So separating to pairs. 6, 1 and 2, 3 is a pair. 23 is not a perfect square. What is the least number than 23? 4 4s are 16. So 4 4s are 16. Subtracting we get 7. Let me bring down 61. 4 plus 4, 8. It is not a perfect square, so we need to try here. So let me multiply 8 with 7. 7 sevens are 49, balance 4. 7 8s are 56 plus 4, 60. 6 not 9, which is very much lesser. So let me check with 8. So 88 into 8. 8 8s are 64, balance 6. 8 8s are 64, balance 6, which is nothing but 704. So which is our acceptable number? So 8 times, here 8 times, 704. Subtracting this we get 5 and here it becomes 11. 11 minus 4 we get 7. 5, 57. So look carefully. This number is called as remainder and this one is divisor. Sorry, quotient. Remainder and quotient. So we need to find which number must be subtracted from the dividend. This is the dividend. From this number, we need to find which number must be subtracted. Why we got this remainder? We got this remainder because this number is not divisible by the given quotient. So obviously, this remainder must be subtracted. When you are asked what number must be subtracted from the quotient means, after performing the long division, you can conclude that what is the remainder? That remainder must be subtracted. What is the remainder we got here? 57. So we can write 57 must be subtracted. This is an easy method. So just remember that whenever you need to find what number must be subtracted, you can perform long division. You will definitely get a remainder. That remainder must be subtracted. Let's go to next sum. Find the the least number that must be added to 4931 to make it a perfect square? So, in similar to previous sum, here we need to find what number must be added. So, we need to perform long division now. For performing long division, we need to separate this one from left to right. So, I am dividing into pairs. So, let's take the first two digits, 49. 49 is a perfect square. We know that 7 sevens are 49. So, I am writing 49 here. Now, we can subtract. Subtracting, we get 0. Let me bring next one, 31. So, 31, 7 plus 7, 14. So the number must I put here is obviously 0, because if I put 1 means 141 into 1, it is 141. So here I need to put 0. That is the general method for long division. For normal long division, we'll put the number required and we'll write the answer. So I'll just put 0 here. So here also 0 and I'll get 0. So the remainder will be 31. But here they are asking what number must be added. For added, I'll teach you one easy technique. The easy technique is find what number must be put here. What we should put? We should put 0 here and also we should put 0, so we get 0. So we don't put 0 in this step. Just go for the very next number of 0. What is the very next number of 0? In numbers we write 0, 1, 2, 3, etc. So what is the very next number of 0? 1. So just put 1 here. 1. Here also 1. So what is 141 into 1, which is nothing but 141. I'll tell you what we should do. So after writing the very next number we need to put. So after writing this, just subtract from bigger number to smaller number. What is the bigger number? 141 minus smaller number 31. Subtracting we get 0, 1, 1. The answer is 110. So the final answer is 110. We can conclude that 110 must be added. So this is the final answer. So in order to find what number must be added, what we should do? We should do the long division as usual, but instead of writing the actual number, we just need to write the very next number. So here I should put 0, but instead of writing 0, what I have done is I am going to the very next number of 0, which is 1. So after writing 1, I got one answer. So subtracting from bigger number to smaller number, I got the result as 110. So we can just conclude 110 must be added. This is the very easy method for what number must be added. Let's go to next sum. Find the least number of 4 digits, which is a perfect square. So we need to find the smallest 4-digit number, which is a perfect square. Okay, let me tell one thing. What is the smallest 4-digit number? We all know the smallest 4-digit number is nothing but 1, which is followed by 3 zeros. That is nothing but 1000. So 1000 is the smallest 4-digit number. Let's check whether 1000 is a perfect square or not. No, 1000 is not a perfect square. So we need to add some digit to this 1000 in order to make this a perfect square. Because if I subtract means that 1000 becomes a 3-digit number. So that is not possible. So I need to find what number must be added. So in continuation to the previous sum, let's find what number must be added to 1000 to make it a perfect square. So following the same steps of previous sum. In previous sum, they have given a question and we find what is the number must be added. So here I am taking the number as 1000 because 1000 is the smallest 4-digit number. Performing long division, I am pairing it this now. So pairing first 2 digits is 10. 10 is not a perfect square. What is the least number than 10? So we get 3 3s are 9. So let me write 3 here. Here 3. The answer is 9. Remainder 1. 100. 3 plus 3 is 6. So what is the general number we'll put here? So whenever we are performing a division like this, 1000. 3 3s are 9. 100. So we just need to put 1 here because 1, 1, we get 61 into 1, 61. So we get 61. But what I told you, whenever we are performing, what number must be added. So here we are going for what number must be added concept. For added concept, we'll never put the actual number. We'll put the very next number. So what is the very next number of 1? After 1, we have 2. So what I should do? I should put 2 here. So 62 into 2. 2 2s are 4. 2 6 are 12. So 124. So let me put 2 here. Here also 2. 124. After writing the number, we should subtract from bigger number to smaller number. 124 minus 100. The answer is 24. So what must be added? 24 must be added. 24 must be added to 1000 to get a perfect square. Let me add 24 to 1000. So adding 24 to 1000, we get 1024. So 1024 is a perfect square, which is the least 4-digit number. The least number of 4-digit, which is a perfect square, is nothing but 1024. We can check that because what is the quotient here? 32. Let's check 32 into 32. 2 2s are 4, 2 3s are 6, 2 3s are 6, 9, 4, 12, balance 1, 1024. So you can check any number, 1001, 1002, 1010, 1011, 1015, whatever number we can check, but we get only this number as the least possible number. So the final answer is 1024. Let's go for the next one. A general, wishing to draw up his 64,019 men in a form of solid square, found that he had 10 men over. Find the number of men in the front row. So there is a general, he wants to make his soldiers in a perfect square. So he is arranging the soldiers in the form like this. So while arranging like this, he got a solid square. So he got a square-like figure after arranging the soldiers. So after arranging the 64,019 men, he got that only 10 men are left. So we can conclude that the men are arranged in perfect square. That is, number of rows is equal to number of columns. So it is a perfect square. So if there is 10 members in the first row which means there is 10 people in the next row also. So each row there are 10 men. Like that they are arranging. So this 10 men which is extra, I am going to subtract this one. Minus 10. Why I am subtracting this? Because they are not in the line. So 164,009. So here what is given? They are forming a solid square. Solid square means we can conclude number of rows is equal to number of columns. Then only we get a square. Number of rows is equal to columns. So number of rows is equal to number of columns means it is a perfect square. So we can do it long division. For performing long division, I am taking 64,009 instead of taking 64,019 because that 10 men are left over. They are not in the line. So we should not take them. So we should only take 64,009. Then only we get number of rows is equal to number of columns. So performing here, I am pairing this. So while pairing, 6 is left out. So here 6. 6 is not a perfect square, but we know that 2 2s are 4. Reminder, we get 2. Let me bring the next pair, 40. 2 plus 2, 4. So let me take 5 times. 5 into 5. 5 5s are 25. 4 5s are 20 plus 2, 225. So 5 times. Here also 5 times. 225 and the remainder is 15. Let me bring the next pair which is 0, 9. So here we have unit digit as 9, which is only possible for 3 3s are 9 and 7 7s are 49. So let us go with 3 3s are 9. Here plus 5, we get 50. 503 into 3. 3 3s are 9, 3 zeros are 0, 3 5s are 15. So the answer is 1509. 3 times. Here also 3 times. 1509. 0. So what is the quotient we got? Quotient is equal to 253. This quotient is nothing but number of rows or number of columns. So number of rows and number of columns are equal. So this is nothing but 253. In the given question, they are asking how many men are there in the first row. Since the number of rows and number of columns are equal, in all rows and in all columns, there are 253 men. This is the final answer. Therefore, number of men in first row is equal to 253. We'll join you with more sums in next video. Thank you.